Hello! So this video is an overview of function notation, and we're going to begin by reviewing sort of like looking at a table and finding a pattern. So it says examine the tables of input and input being x and output being y, and find the relationship between the input and the output. So reviewing from a while ago, I'm looking at my y values and my x values, and I see that the x values are increasing by 1 each time. So -3, -2, -1, 0. They're going up by 1, which is the easiest thing to deal with, because then if our x values are going up by 1, it's easier to talk about what our y values are doing. So our y values go from 8 to 3, which is subtracting 5, and then from 3 to -2 is also subtracting 5, and then we have subtracting 5 again, and just verify that your pattern maintains throughout the table. So it seems that this rule has a constant growth rate or slope of -5, so that's going to mean it's linear, so we're kind of going to be in the form y equals mx plus b. So now we know probably in our rule is -5x, and then my 0 term, when x is 0, y is -7, which means -7 is the y-intercept. So this rule is y equals -5x minus 7. And just plug in a number to verify that. So -5 times 2 is -10, minus 7 is -17. Make sure it works for all points. And the second table, again, our x values are the same. They're increasing by 1. And the y values from 8 to 3 is a decrease of 5. From 3 to 0 is subtracting 3. So from 0 to -1 is just subtracting 1. And then from -1 to 0 is going up again by 1. And then up by 3 and up by 5. So this pattern is definitely not a linear pattern. So could it possibly be a quadratic pattern? Well, if you would plot the points, you would definitely know it's a quadratic pattern. Another reason why we know is because we see the symmetry in the output values, like 8 here, and then 3, and then 0, and 0, -1. So 0, -1, first of all, is our y-intercept. So that means the rule is going to have a -1 at the end. And second of all, it has a vertex at 0, -1, because that's where it turns around in the table. And also, so this point right here is our y-intercept. So here, these 2 points are where y is 0, so that's our x-intercepts. Which means we would have factors x minus 1 and x plus 1. And if we multiplied that rule together, just go up here real quick, we would get x minus 1, x plus 1, x squared, -x, x, and 1. So the negative x and the positive x would cancel. So I'm thinking this rule is going to be x squared minus 1. So let's test it out. If we take -2 and square it, that would be +4, and then -1 is 3. And then here, 3 squared is 9, minus 1 is 8. So we have 2 rules. And now it's time to read through these notes together. So another way to write rules, which are called functions now, is to write them using function notation. And the only difference is now we're referring to the output as f of x instead of y. So in quotes above this notation f of x, I'm going to write f of x because that's how you read that. And a couple things that are really important about interpreting this are listed here in the box, but let's just go over them really quick. So first of all, this f is not a variable, right? You're never going to plug in something for f. It doesn't have a value. It's the name of the function so that we can tell which function we're talking about. So we're talking about f of x, and it's pretty much used, the most common letter is because f is the first letter of the word function, but other letters can be used, so you could name something. A lot of times we see g of x used for the name of a function rule, or h of x, or it could be really anything. It could be m of x. There's lots of letters you can use. And then the of x part, so that x tells you what input to use to get the output. So when you see the notation f of x, it just refers to the whole rule. But then when you replace the x with a number, it refers to the output of that specific number. So we're used to seeing y equals x squared minus 1 up here. And x is our input, and then y is the output. So now it's just going to be, instead of y being the output, f of x is the output. And sometimes we're going to be asked for a specific output number, which is what this x is telling us. So let's rename the functions that we just wrote above from our tables. So now the only difference is, instead of y equals negative 5x minus 7, we're going to use f of x equals negative 5x minus 7. And we're going to say, instead of y equals x squared minus 1, g of x equals x squared minus 1. So now automatically we have a way to determine the difference between which rule we're talking about, because before they were both y equals and y equals. Well, now one is called f and one is called g. So f of x is our first rule and g of x is our second rule. And so now if we see something like this, f of 2, that means we want to know the output for when x is 2. So this 2 is telling us to plug in 2 for x into this rule f of x. So f of 2 is going to equal to whatever negative 5 times 2 minus 7 is. So negative 5 times 2 is negative 15. Nope, just kidding. Negative 10 minus 7, which is negative 17. So we actually saw that one in the table above. So the input of 2 gives us the output of negative 17, which is right there in the table. So it's just a different way of writing and talking about input and output together. Let's try another one, g of 10. So g of 10 means I'm going to plug 10 in for x into the g function, which is x squared minus 1. So we're going to calculate what is 10 squared minus 1. Well, that would be 100 minus 1. So that means g of 10 is equal to 99. So for the function g, if you plug in 10, you would get out 99. And again, now we're switching it up. G of negative 5. So you have to be careful to use the rule that's labeled g of x. So negative 5 squared minus 1. Plugging in x into the g function rule. So that's 25 a positive 25 minus 1, which is 24. So the output is 24 when the input is negative 5. And the last one is f of 4. So plug in 4 to f of x rule. So negative 5 times 4 minus 7. Run out of space to push the paper here. So that would be negative 20 minus 7 for negative 27. So now, a little bit more about this. So remember how up here we had a table of values, and we're used to the coordinates being x, comma, y. Well, they still are essentially input, comma, output, but now, so if we just calculated that f of 4 is negative 27, so fill that in here. Just a reminder that that means that the point we're talking about is 4, comma, negative 27. So if you were going to graph f of x, you would plot the point for negative 27. All right, so now real quick we're going to make a graph of this function, which is f of x is equal to the absolute value of x minus 3. So we have a table which usually would be x, y, but it's x, f of x, but it works just the same way. So f of x means we're going to plug in these x's into the rule here. So we'd have the absolute value of negative 1 minus 3, which we do what's inside the absolute value first. So that's the absolute value of negative 4, which is a positive 4. And I'm going to keep plugging in the values. And I would encourage you to pause the video and try to do this yourself. So I'm actually going to pause because I'm running out of time. Okay, so here's your filled out table. And notice that in the negative, when we were getting negative in there, everything was coming out positive because it's absolute value. And then even when we switched around here and things started coming out positive in there, they would still come out positive because of the absolute value. So this means that we're going to plot the points negative 1, 4, 0, 3, 1, 2, 2, 1, 3, 0, 4, 1, and 5, 2. And then this would be a continuous graph, so I can connect those points. And that's the graph of the function, absolute value of x minus 3. So reflecting on these questions, what does the graph look like? I'm going to have you fill that out in your own words. Did all of the inputs work? And what do you notice about the output values of this function? So these are some observations that you should make on your own, and I'll be looking for your answers to these questions the next time I see you in class. All right. Make sure you write down any questions you have about function notation and ask them the next time you see me. Bye.